So assuming that we have a matrix in memory, how do we go about accessing a subset of that matrix? Well, we want to use the square bracket operator and provide vectors with the desired rows and columns separated by a comma. So that may sound confusing, so let's talk some more details. So let's say A is a matrix, then we can select a subset of A using the syntax A, and then you see we have the two square brackets here, and then R comma C. R is going to indicate the rows that we want to obtain, and C indicates the columns that we want to obtain. So we're going to extract almost always kind of a square section or a rectangular section of our matrix by specifying that. If we select only a single row or column of our matrix, then you have to be careful because the subsetted object is going to simplify to a vector object instead of a matrix. So it actually changes object type, which personally I don't like, but it's something to be aware of. That's just how R does things. If we don't supply a vector of rows or columns, then all of the rows or columns are going to be returned for that particular argument. So we just have a blank there. We don't put anything there, and then R assumes you mean you want all the rows or all the columns respectively. You can also use minus notation to indicate all but the specified rows or columns should be selected. So this is similar to the minus notation that we use for data frames. You can use it for matrices as well. Be careful, it is a little trickier, but it can be very convenient at times. So let's do a set of examples to better understand how to use this syntax to subset part of a matrix. So let's create a 4x3 matrix B below. It just has the elements 1 through 12. And you can see we have 4 rows, 3 columns, 1 through 4 is the first column, 5 through 8 the second column, and 9 through 12 is the third column. Let's say we want to select columns 2 and 3 of our matrix B. Well, we indicate the name of the matrix. We have our square brackets here. We want all of the rows, so we're going to leave the row part blank. And then after the comma, we're going to specify 2:3, which means we want to select columns 2 and 3 of our matrix B. And you can see here what we get is only the final 2 columns of B, so we got exactly what we expected. Let's say we wanted to select rows 1 and 4 of B, assuming we wanted all of the columns. Well, then we indicate the name of our matrix. We use our square brackets. In the first position here, we have the vector with the values 1 and 4. And then after the comma, we leave it blank because we want all of the columns associated with our matrix. And so when we do that and compare that to what we had before, you can see that we are only selecting the information in rows 1 and rows 4, row 1 and row 4 of our matrix B. You can specify both simultaneously. So for example, if we wanted to select columns 2 and 3 of rows 1 and 4 of B, we can run this command. So you can see we have the name of the matrix, we have the square brackets, we indicate the row columns we want, the column vector, the columns that we want in our matrix. And when we do that, you can see that we only get the information in row 1 and 4, columns 2 and 3. And so that's exactly what we have here. What if we wanted to select all columns of B except the third? Well, then we can use this minus notation here. We have -3 in the columns position. So we'll get everything but the third column. And you can see we only grab the first 2 columns of our matrix B. But note that if we only select a single row or a single column of B, then it actually simplifies to a vector. So you can see the format changes here. And this is what it looks like when we're running this in a Jupyter Notebook in Colab. It looks a little different if you're running it in R through RStudio or something similar, but you're going to see that the dimension is going to collapse. And so this is a vector, this is not a matrix. This is also not a vector, or this is also not a matrix, it is a vector instead. So this is, in my opinion, undesirable behavior that you need to be careful about. So if you want to retain the matrix structure of a matrix when you select only a single row or column, then there is an additional argument drop that you can specify. You want to change that argument to false, and then that ensures that we actually keep the result in a matrix format instead of an array format. So you can see here if we select the second row of B and specify drop equals false, we do in fact return a matrix with 3 columns like we would expect. And if we select only the second column of B and specify drop equals false, we once again return a matrix instead of a vector. Let's say that we want to extract specific elements of a matrix object and not just a rectangular subset of the object like we've been talking about previously in this video. If we want to do that, then we can actually use a matrix indicating the elements we want to extract inside the square bracket operator. So let's say we want to extract the elements in positions 1, 2, 3, 1, and 4, 3 of some matrix. We're going to create a matrix that describes these positions, and each row of the matrix is going to describe an element we want to extract. So I create this matrix pos, and I'm binding a vector with the values 1, 3, 4, and then 2, 1, 3. And when I see the result here, I can see I have 1, 2 in the first row, 3, 1 in the second row, and 4, 3 in the final row. And if we pass pos inside the square brackets to the matrix B that we created earlier, we can see that we get a vector, because it simplifies to the lowest possible dimension, with the values 5, 3, and 12. And if we go up to the matrix B that we had previously defined, we see that in position 1, 2, we have the value 5, in position 3, 1, we have 2, and in position 3, 4, we have 12, which is exactly what we obtained when we passed the pos matrix that had the elements we wanted to extract inside the square brackets to B.